My name is Mark Stiles, and I'm presenting my portfolio from the Master's in Applied Data Science program at Syracuse University. I sought an advanced degree in data science because I've been working towards it for almost 10 years now. Up until now, I built my career with a bachelor's in computer engineering as a software engineer building web applications. But the last half of my career has been in pursuit of developing learning algorithms to help make these web applications more intuitive. Before the program, I lacked the scientific rigor to collect and mine data, design features, train models, and communicate insights. This is why I applied to this program. I followed the artificial intelligence track, which was my core interest. And throughout this program, I learned what problems businesses were facing with the data they've collected. I learned how to break those problems down and analyze them. I learned what data is, how it can be calculated, processed, and stored. I learned how to build sets of models and tune them from the data, finding the best solution possible. Because of this program, I learned the big picture. I now feel prepared to solve the complex, difficult data problems in enterprise systems today because I have a solid foundational understanding of data science. The following projects are the results of my abilities as an outcome of the work I took in this program, and I will examine this work to provide evidence of my mastery of the principles of data science. Exhibit 1, Deep Learning. This was my main interest, and in this course, I focused on predicting the revenue for any single U.S. city based on their economic and demographic data. Local city officials offer tax and housing incentives to entice companies and people to move there, help them provide better services, and continue improving their city. I wanted to learn how this cutting-edge technology could apply to the problem of local government. If they knew what factors impacted their revenue based on modeling and had the tools to explore the effect those changes have, that could help them target better incentives, better investments, and prepare for downturns. The data set I used was scraped from the Census Business Builder website, which required combining geodata to produce a list of economic and demographic information for all cities in the US. The final data set had 9,708 observations and 54 variables, and it took almost a week to generate. To build the neural network model, an iterative approach was used to test the size and tune the hyperparameters to construct the most efficiently trained model. By running repeated tests to find the right scale model first, I was able to spend more time cleaning the data, improving the model accuracy, and less time waiting for training complete. The model, once trained, was then used to power a web application that demonstrated how you could find your city, update the values to next year's values, and predict the resulting revenue. Here I wanted to show that I had the vision to develop a solution end-to-end to solve a challenging real-world problem. Exhibit 2, Information Visualization. This course provided me an opportunity to push my creativity and explore personal correction with the data set. The data was about residential home sales. And I was recently a home buyer, and I've been watching as the federal interest rates have been increasing rapidly over the last several years. These increases were unprecedented and directly affect how homes are bought and sold. I wanted to know what effect this had on the housing market and on the buyers and sellers like me. I combined 10 data sets from Zillow Research. The data set spans 6 years and contained 26,271 observations and 24 variables. My analysis focused on the difference between the list price and the sale price as an indicator of the market health, as well as how mortgage rates change from before and after the rate increases. The first graphic I produced was intended to hit the wow factor. It shows where the mortgage increases hit the hardest, while highlighting that even the average mortgage was now more than double. This graphic shows how the average home sale price trajectory changed shortly after the COVID lockdown, and then had a startling drop and restart following the rate increases. This graphic shows the average mortgage rate and how much that effect the rate increases had on doubling that mortgage rate. That's a hard hit for the average household. This graphic reveals a trend of an increasing number of people paying above the list price, starting right around when the COVID lockdown started. And this, for me, it was the best graphic I made. It identifies a few different stories. The interquartile range indicates that most people actually pay less than the list price for a home. The other thing is that the people paying more than the list price are doing so on modestly priced homes, whereas people paying $800,000 less than the list price are talking down the cost of very expensive homes. The really curious thing is what caused a surge in the people paying close to or more than the list price in 2021 to 2022. I wanted to find something unexpected, and I did. And this really helped me deliver that message in a compelling way. Exhibit 3, Database Administration. This course allowed me to build an idea I'd wanted to create for many years. I was focused on the value of digital artists and media, and what I envisioned was a marketplace where anyone could post the media they created. Anyone can then purchase it, license it, or commission an original work. This would allow them to build more complex songs from samples and generate a hum of creative economic activity. I learned how to spend time understanding the business problem and build the information architecture correctly from the start. I spent time researching the intellectual property business models like the entertainment and technology industries to develop the data structure to handle the buying and selling of copyrights or their subsidiary licenses. Here I built the external application schematic, including landing page, forms for user registration and payment, forms for uploading and licensing assets, as well as forms for selling those assets and licenses. And to complete the idea, a custom web application was built using it, which demonstrated the database in action with the two users that I had created, one to create the property and the other to consume it. Here again, I want to emphasize the end-to-end thinking that completes an idea from conception through to implementation. Exhibit 4, Applied Machine Learning. In this project, I chose to analyze an e-commerce website's product offerings. The data was from Flipkart.com, a laptop seller. This dataset contained 984 observations and 13 features. One of the first tasks was to break up the price into consumer segments. In this case, we named a cost category. The goal was to understand what laptop components made up each category and to build a classifier to help business set prices for new products or target marketing to improve customer lifetime value. I was instilled with the concrete understanding that there's no one solution to a problem, but a continuous journey of discovery to find the best solution possible at any given time with the data that you have. My only regret is not having taken the visualization class first. The analysis focused on marketing cost categories whose distribution is shown here. They show that most sales are in the consumer range. This plot shows that most product prices are below $1,000. And looking deeper at the breakdown of brands in these categories shows that not all brands support all cost categories, or even the most common one. There's potential for missed opportunities here. And the nonlinear relationship in these graphs means that for each progressive improvement to the laptop components, you're fast reaching a hard limit on what the average consumer will pay and what might not be worth investing a lot and keeping in stock. This plot shows how small numbers of observations in high values can be misleading and indicate that price drop at the highest levels when they're actually well within the range of values expected there. An a priori rules analysis of the dataset showed that the commercial grade laptops were actually bad deals. Now, this was an engineered feature that manages a balance between cost and value, but this is the type of insight that would be worth looking into to improve the products within that category. To build a predictive model for this dataset, we trained a suite of classification and clustering algorithms, including expectation maximization, k-means, random forest, and naive Bayes. A few of the models we produced were able to reach an extraordinary level of accuracy. But it's always important to check one's assumptions and ensure that the models demonstrating the highest accuracies aren't just actually overfitting the data. Now, throughout the program, I was challenged to develop a mind for scientific thinking about data. Each course required finding and preparing a data set, exploring the data for insights, building a quality predictive model, but also knowing the impact of how these insights and models may apply to the real-world scenarios, good or bad. I feel prepared to work in the field of data science and have a meaningful impact. With each project, I attempted to find data that was relevant and complex so that the effort I applied would result in better understanding of the work I'll be doing to solve current business problems. I experienced the difficulty of repairing data sets with incomplete or bad data. I felt the strain of trying to explore at depth in more directions than time allows. And I can see how challenging it can be to develop a model for a problem unless you understand the strengths and weaknesses of each algorithm. I confidently move forward knowing the tools and processes that will help me succeed in converting raw data from a vast expanse of text and digits into clear insights, quality models, and impactful business value. Thank you.